creating that. I'm going to create a read and write token, and I'm going to configure it with the hcloud CLI. So we can create a server from the CLI, from the terminal. Paste in the token that I perhaps didn't properly copy. Context created and activated. Let's quickly check whether it works. It does work. Okay, then let's get rid of the screen and also the secrets. Okay, welcome back. As you can see, I created a new context using hcloud context create, and then just tested that some API request worked. Okay, now we can create a server. And to get started, we really don't need anything else besides a simple server. So let's create one. We need to provide a few flags for it, required information to create the server, like the image, which is just gonna be Ubuntu 22. We need to define a type for this, which is gonna be CPX 11, and a name. Let's just call it cube for now. Oh, I forgot something. We should also create a SSH key before, so we can use it on the server, and then we can directly log into the server. So hcloud SSH key, create, and then we can say public key from file, and just give it some file in .ssh id rsa pub. And we can probably also give it a name, and we're just gonna name that episode. Okay, now that we got the SSH key, we can go back to creating the server here and pass it the SSH key. There's one flag missing, and that is the location. Where do we actually want the server to live? Cloud currently has 5 locations: Falkenstein and Nuremberg in Germany, Helsinki in Finland, and Hillsborough and Ashburn in the United States. I'm just going to deploy to Falkenstein. And now we see that the server is being created. And we got an IP address, and we can use it to connect to our server, or what we can also do is use the hcloud server SSH command and just tell it to connect to the server queue. Asks us to confirm the fingerprint, and here we are on our Kubernetes node. No Kubernetes cluster yet, but a Kubernetes node. Okay, next we need to bootstrap Kubernetes on it. And for that, I'm going to take a quick peek at my works project, because here we have a quick little setup script, dev-up, which automates a lot of that stuff. Also around setting up k8s for tests, or for a development environment. It creates SSH keys, whatever. I thought about copying it, but just for the first time, I'm gonna do it manually. So let's check out how it actually creates the Kubernetes cluster, and it uses k3s up. But the join command is the wrong one. We want the it was just there. K3s up install. First node is control plane. K3s up install, and we can, I guess, just copy all of this stuff and then maybe maybe pass in some variables here. I hope this is not too boring for you. Let's make sure that I have KS3 up installed. I don't. Let's install it locally. Yes, please. I mean, K3s is like a simpler, slimmed down version of Kubernetes. Usually with Kubernetes, you got like all these different processes that you need to run. The API server, etcd as the database, 2 or 3 further controllers, the kubelet. And with K3s, all of that is bundled up into one binary that is easy to start. And K3s up makes it even easier to just bootstrap a cluster locally, and it sets up all the dependencies and what else. So I found that really nice for the development environment. Okay, let's see if we can get those commands in here. Oh, there's a lot of stuff that we need to fill in. A lot of blanks here. Okay. Let's see, we need to get the IP. For that, we're just gonna say hcloud server IP cube. That should get us the IP for the node. Then we have the channel, which is the Kubernetes version. Let's see what channel we have here. Channel, it's stable. That should be 127 right now. Then we have some extra args server opts. Disable cloud controller. This is important. By default, K3s, because it is as simple as possible, it comes with a default cloud controller manager, which we don't really want because we are going to build our own, and otherwise there would be conflicts. And we also need to configure the cluster CIDR, which is like the range of IPs that pods get assigned. We're just going to take the default from our script here. Then we have some further K3s opts. These are kubelet args. We need to tell kubelet that we are going to use the external cloud provider, which we are going to build right now. And we also disable most of the additional things that K3s comes with. And then we have the node IP opts. K3s node IP opts. And here we have the node external IP. And also the option to set a private IP, but because we don't have a private network setup right now, we can safely skip that for the moment. Ooh, I accidentally pressed Ctrl+C. It has a weird key binding. Sorry, it's the first time working on Golang on this computer. And I'm used to pressing Ctrl+Shift+C in terminals. Why though? Why does it need to be this annoying? What? Okay, this is looking better. Node external IP, and let's just write it in there manually. hcloud server IP cube. Then we need to define a local path where it will put our kubeconfig, and the kubeconfig will just go to kubeconfig.yaml and an SSH key, which is .ssh. I guess we can just leave that out and it should still work because it should automatically find the key. Okay, we can see that it's running K3s up install, and on the node it's downloading K3s, creating some symlinks, enabling K3s, and it failed because of some reason. So let's check that out. Server SSH let's look into, this is gonna get annoying. Let's look into the logs for this. Network manager. Hello. Fail to start. Cannot run executable found relative to current directory. What? What is the problem? I wasn't expecting any issues here. Command looks reasonable, that it's trying to start. Let's check whether that's actually defined. K8s is there, K8s server also should work. What is the issue here? If any of you in chat know, please feel free to tell me what the issue is. Well, it's running now. Let's see if it put the kubeconfig there. No, it didn't. Okay, let's try to run this command once more. I don't know if it can actually do that. Yeah, it is able to. Okay, now we got the kubeconfig. Let's quickly create a git ignore. And put the kubeconfig.yaml in here so we don't accidentally commit that. And then let's export kubeconfig equals kubeconfig.yaml. And then we should be able to do kubectl pods in all namespaces. And here we see 2 pods that are currently pending. And especially interesting, we can see the nodes. We see the node because we only have a single node. And here we have a taint node cloud provider kubernetes.io/uninitialized. And this blocks the pods that are currently pending from being scheduled here, but also this is the taint that the cloud controller manager removes after it has initialized the node. So once this disappears, we know that we have done a good job. Okay. Also, it complains that the CNI plugin is not installed. We can actually also do that right now by running this is the registry. Yeah, here. This is Cilium. So let's install Cilium in the cluster. Cilium is a container network tool thingy. And we don't really need any of that configuration. Why is it so complicated to copy and paste something in here? Sorry if I'm struggling a bit today. It's a long time since I've streamed the last time, and I'm a little bit nervous, as well as I haven't done a lot of development on this computer desktop PC in a long time. Let's get rid of all these flags, and that should be enough to install. Okay, let's get the pods again. And we can see that it is deploying some Cilium pods here. We can also watch them to see that they are initializing and now running and ready. Nice. So our node is now really ready to receive some cloud controller handling. Okay, now that we have finished that errand, let's start our Cloud Controller Manager again and see where it fails. Neither kubeconfig nor master was specified. Okay, I was hoping that if I just provide a kubeconfig environment variable that it would work. But let's define kubeconfig, and that's just the local kubeconfig file. Let's run again. No authentication kubeconfig provided in order to look up client CA file. Okay, so these are just warnings, but then we have a fatal error down here. Cloud provider could not be initialized. Unknown cloud provider hcloud from scratch. Okay, that is expected. Because in here it tries to initialize the cloud provider defined by the name we provided through the command line, but this is the only place where we have ever defined this name. So we kind of need to define our own cloud provider. Let's check out how it's done according to the docs. Okay, so it doesn't. Love that this example isn't even complete, and that's exactly the reason why I wanted to make this tutorial series, because I think that it's hard to get started with most of these tools. I think Cluster API does a good job, but most others are missing like a intro series to writing your own cloud integrations. Okay. Let's just check out the code that we have in our existing Cloud Controller Manager for hcloud. And I know that it should be in hcloud. And there should be an init function somewhere around here. Let's look for init. Init, yes, hcloud go. Oh, I was right here and just scrolled past it. Okay, so in here we call cloudprovider.register cloud provider with a provider name and an initializer function. So let's copy that for us and create a new directory in here, perhaps. Let's just call it CCM, and then we create a new cloud.go. Like, why isn't this mentioned in the docs that you need to do this, and then all the following steps are logically that they follow because you need to like define these variables and give them some purpose. Okay, let's define a variable provider name, which is equal to hcloud from scratch. And then we need to import this so that the init function is actually running. So let's import this. We need to import it with an underscore because otherwise Go format would remove it because we never used that import. So let's do CCM, yeah. And now the init function will run and this package will be included in our build, and it will fail because we got an undefined variable in here, new cloud. So let's check out what it needs to be. Register cloud provider registered registers a cloud provider factory by name. This is expected to happen during app startup. Register cloud provider, name is string, and cloud is a factory. Okay, and then it just puts it into a map, and later during the startup it reads from this map based on what we provide to the cloud provider variable here. Again, this is a little bit too complicated if you consider using it as a library for your singular cloud controller manager, but this code is also used in the kubelet, which still has as a legacy baggage, which still has a number of in-tree cloud providers for, I don't know which ones are still there, but there was like OpenStack, AWS, Google Cloud Platform, vSphere, and they were all built into the kubelet binary. And then that's why you need this selection mechanism to select which cloud providers actually ran. And that's why we needed to provide the, if we go back to k8s up, we had the kubelet arc here. We also needed to provide the cloud provider equals external flag to the kubelet to tell them that no, you shouldn't actually run any cloud provider, but expect that it's running external to the kubelet. It's still some legacy that's hard to get rid of because, yeah, they got like millions of clusters running, and migrating out of that is quite hard if you start doing it. But most cloud providers are now out of the kubelet, and yeah, it's an active process. Join the SIG cloud provider if you're interested into that. Okay, let's check out what a factory needs to be. It gets a config reader and returns the interface. And as we know, the interface is just this interface that we checked out earlier. Okay, we can do that. Let's copy that and define a new function here. New cloud. Where is this defined? This is cloud provider.interface. And then this IO should be control plus. It should be, yes, just the stdlib.io. Okay. Let's give it a body. And now we need to think about what interface do we actually need to build. Let's define a new struct type cloud provider struct. And then we can say that this struct should implement interface cloud provider interface. And then it auto generates the full interface for us, and we can just go in there and write the methods. Initialize. What does initialize need to do? Let's check it out. Initialize provides the cloud with a Kubernetes client builder and may spawn Go routines to perform housekeeping or run custom controllers specific to the cloud provider. Any tasks started here should be cleaned up when the stop channel closes. Okay, so let's just wait for the stop channel, and we don't really need the client builder for now because we don't talk to Kubernetes ourselves. Easy peasy, 1 out of 8 done. Nice. Load balancer, not today, so let's just return nil and false. The interface says load balancer returns a balancer interface. Thank you for the typo. Returns a load balancer interface. Also returns true if the interface is supported, false otherwise. We don't support load balancer for now because we are just getting started. So let's return false. Instances, same thing. Right now we just return false for everything, and then we get to actually implementing any of these later. Provider name. just returns a string. So let's check out that one. Returns the cloud provider ID. Okay, so let's return the provider name. I think that is fine. The variable is literally named the same. Don't really know what else it expects from us. And then a has cluster ID. Returns true if a cluster ID is required and set. So far, I didn't understand what a cluster ID is. So let's just return false and say that we don't support it and don't know what it is. Okay. Now we have a interface that we can return. So let's return a new cloud provider. And we didn't encounter any error, so we can return nil for that. We also didn't need the config. Let's try to run this and see if it lands us in trouble again. Probably will. Why, yes, this one. Okay, no cluster ID found. A cluster ID is required for the cloud provider to function properly. This check can be bypassed by setting the allow untagged cloud option. I still don't know what a cluster ID really is, so let's just set the option. Untagged cloud. Okay, nice. This has gotten us further and the program didn't crash. So let's check what it logged. Generating self-signed certificates. No authentication. Kubeconfig provided in order to look up. Detected a cluster without cluster ID. The version of our program that it's serving something on a port. It's acquiring a leader lease. And we became the leader. And then it logged an error, unable to get all supported resources from the server, unable to retrieve the complete list of server APIs. Okay. That might or might not be a problem. Let's open another tab. Actually, let's stop this and move it into a run configuration. Oh, sorry. Hope that was muted. Let's move it into run configuration so we can later easier debug this. Yeah. So this is a. Can you do just like a go? Okay, so that's probably go build. Why is it called go build? Ah, okay, run after build is checked, so that should also run it. We have a single environment variable that's kubeconfig, and the value is kubeconfig.yaml. Oh no, that wasn't an environment variable. That was an argument, right, for the program. Let's just copy them. These are the arguments. Okay, everything got yanked again. Program arguments apply. Okay, and now we can just tell it to run the controller, and then we can easily debug it, and we have a separate console for the program. Okay, so let's check out our node. And check whether the taint has been removed. No, it hasn't. Some other taints have been removed, but the cloud provider uninitialized taint is still fully set and there. Also, none of the labels are there, but I would say all of that is expected because we haven't implemented any of the interfaces yet. Okay. Can we get a watch on this? Can we do something like JSON path? Let's spec.taints. Does it work like that? JSON path. Okay, nice. So that shows us all the taints of the node, and then we can watch that, and whenever the taints update, we get a new empty array, probably when the taint is removed. So we have a quick way to check this. Okay. Yeah, let's start by implementing instances v2. Let's make a new file in here for the new interface. Instances v2.go. And in here, let's define again a struct type instances v2 struct. And then we go in there and say implement interface cloud provider dot instances v2. Okay, let's get the context. Oh, did it so automatically. Okay, and for now we could go in here into instances v2 of our cloud provider and just say return instances v2 a new struct, and true, because now we support this. And if we restart our running process here, then at some point it should panic because it tries to call the methods in instances v2, and that fails. Hey, Faku Karancho, thank you very much for the follow, much appreciated. I hope you're learning something. I certainly am today. If you got any questions, just write in chat and I will try to answer them as well as possible. Okay, it still looks like it hangs up on the retrieval of the list of server APIs, metrics, stale group version discovery. Okay, so this happens because, as you might remember, we got the metric server and that pod is still pending. And the metric server serves this API, and as long as it's not available, it can't serve that API. So the question is, how would that even work on the cluster bootstrap? Okay, can we disable the metric server is the better question, and will that help us? Let's check out the k8s documentation, and maybe it tells us how we can disable it. Metric server. Let's see. So there is a number of disable flags, but nothing for the metric server. Let's see the expose metrics. Okay, so there is a generic disable flag where we can delete the metric server. Now, how do we modify the flags of our running cluster? Let's SSH into the node. Cloud server SSH cube and check out our systemd service for k8s. And maybe that has some references to the configuration file. This is a lot of quotes. Okay, this is the full configuration of the service, and here we have an exec start, which gets a number of flags. So perhaps we can just modify the service here. Where do I modify the service? Let's check out where it is. It's this one. Okay, looks like I can just put it in here. Disable metrics server. Okay, and then you need to reload the daemon, right? After you modify a service file. System kernel daemon reload. And that reloads all the files from disk, and then we can say restart k8s service. And now we should have a status k8s service. Yeah, now it's running again, and it should be disabled. Let's check from localhost if we still see the pod. Nope, pod was removed. Let's check out our running program. Let's restart that. Only once it has acquired the leader lease, it will actually do something. Perhaps we can change the configuration so it does a graceful stop. Not sure if that's possible here. Maybe something to figure out for next time. Okay, so we became the leader. And now it should start the controller loop. It doesn't. Okay, let's use the debugger perhaps. One good reason why we configure it like this. Let's use a debugger and just put it on the new cloud, which I would expect gets called with our cloud provider, for our cloud provider. And then we can just follow the execution of the program to see what happens. Okay, so we are in new cloud, and this gets called from cloud provider in cloud provider, calls get cloud provider, calls new cloud. All of that happens inside our cloud initializer here in our main.go. Okay. So let's step out of this, out of this, out of this. Sorry. Okay, so now we have a cloud, which is our cloud provider. And yay, that worked. In the command, we have the cloud provider. Next, the controller initializers. Ah, yes, what are those controller initializers? Let's check them out. Cloud provider app. Okay, so it has a number of initializers here in the map. And then I would expect it to start those. Run. Leader election. Set setting up some webhook ports, which I also don't understand why they are necessary. But we had a recent bug where the port was blocked in our code. Okay. Right. We are waiting on the lease, and then I probably forgot to set the right breakpoint. So let's set one here. And perhaps also set one here. Now it's probably too late because we already got the thing. But let's wait here. We can just pause the execution and check out where all of our runtimes, Go routines are currently, what they are currently doing. So the main one is just waiting on the stop channel. This is gonna get boring because we got like 20 to check. Just checking if it's somehow blocking on our code or what the deal is. Can I? Be nice if there was a shortcut for this. Lots of Go routines related to GC, garbage collection. Okay, here's one that is waiting on some network connection. Makes sense because we have some ports open somewhere. Create controller context. API server. Okay, also doesn't look like our code. Sorry, this is really boring right now. I just have no idea where we are blocking. Dynamic serving certificate controller is also outside of our code. This is watching for events coming from Kubernetes API server. Same. Work queue also related to the controller setups, but that's a good thing that they're already up and running. So maybe they're just waiting for things. For things to happen. Leader elect and run. Okay, this is related to leader election. Cloud provider initialize. Okay, so it calls initialize, and I did an oopsie. This is the function that we implemented, initialize, and it passes the stop channel. And based on the documentation of the method, let's check it out quickly. Where is that? Here, initialize. Let's go to the documentation. Any tasks started here should be cleaned up when the stop channel closes. So I was expecting that I could just wait on the stop channel to finish until I return from the function. Like this was already being run in a Go routine. But I would need to run that in a Go routine. But I don't need it. I don't need to wait for the stop channel. I can just do nothing here because we don't have any initialization tasks that we want to do right now. Nice. Okay. Let's try to run it again and see whether that actually fixed our problem of not running. Maybe I should disable the leader election for now. Okay. Now we got further. Let's check out the notes here. Configure cloud routes is set, but cloud provider does not support routes. Will not configure cloud provider routes. Expected. Skipping node root controller, started node controller, started cloud node lifecycle controller. Failed to start service controller. Does not support external load balancers. Also expected. Initializing node cube. This is the one node we have with cloud provider. Okay, so it's actually trying to do something. And then it complains, observed a panic, implement me. Because we actually panic here. Implement me. Okay, nice. So we got it working. It calls into our code. And now we just need to make it work. Let's quickly add all of that. And then we need to think about how to get the data that we need. Right, so what we could, of course, do here is just say return instance exists, true nil, instance shut down, false nil, it's running. So just hard code the data that we have here. And then return cloud provider.instance metadata, and then just hard code some stuff in here. But that's probably not what we want. So we need to figure out how to get this data. How do we figure out what ID this has in the hcloud API, what instance type it is, where it is located, and stuff. But for that, we kind of need access to the Hetzner Cloud API. Luckily, the Hetzner Cloud has a Go SDK, which I'm also maintaining at my usual job. So let's try to just put a client in here for this, and that would be hcloud.client. And let's import that. So that would be github.com/hetznercloud/hcloud go v2 hcloud. Yo, what's up? Kubematisiert. Welcome to my channel. First time viewer. Hello. Today we are working, let me just give you a rundown. Also a lot of viewers, probably not all here since the start. We are building a Kubernetes Cloud Controller Manager from scratch, using the Kubernetes Cloud Provider library. And yeah, the Cloud Controller Manager is responsible for a number of tasks related to talking between Kubernetes and your cloud provider. And right now we are doing the first thing, the node controller, which informs Kubernetes about the existence or non-existence of Kubernetes nodes, and also the ID in the cloud provider, and where it's running, what kind of server type it is, what network addresses it has. Yeah, and we got it as far as our binary runs and then crashes because we didn't implement the interface properly. We just panicked. And now we are working on getting actual data back for all those fields. The question is, sorry, I'm relatively new to Kubernetes. For what is the Cloud Controller Manager good? Does it mean I can orchestrate new node from Kubernetes itself? No. For that, you would need something like the cluster autoscaler or cluster API. There you can create new nodes in your cloud provider. The Cloud Controller Manager is responsible for setting metadata on node objects, just talking to the cloud provider's API and seeing, does this node exist? What are its server type, addresses, health status, and then also for setting up load balancers. So it takes the list of nodes that are available and makes sure that a load balancer is created in your cloud provider. If in Kubernetes you have a service type load balancer, it will take the configuration from that and mirror it back to your cloud provider. I'm just going to link you some extended documentation that you can read through that explains it all in probably way better words and more details, more detail than I can provide here. Okay. Yeah, no worries. Always there to provide some guidance. I mean, it's what this series is for, right? Okay, so we've embedded the client here in our struct. And now we could do something like check the node. Because we receive the Kubernetes node in our API. And we could go in there and say, what is its name? Because we know that the name is defined. And for now, we could just log this actually. How do we log here? Good question. Hello, Reductos. Nice that you're here checking out the stream. Hope you can learn something. Okay, there's an extra S that we don't need. Let's try to run this again. Oh, this leader lease is annoying. Let's disable the leader election and just hope that we don't run multiple at once. Leader election false. And that's the wrong flag. You would think I would know, as I was just working on this yesterday. But yesterday is not today. It's just leader elect. Leader elect false. Okay. Let's try again. And that very quickly fails. Wonderful. And we can see our log name here. Node name is cube. Nice. So what we can do is we can check with our cloud provider. So we can use i.client.server.getByName. And we can pass it a context, which we luckily already have because one was passed to us. This context is used, for example, for like a timeout, if they've done a good implementation of it. So if we spend like 5 minutes waiting on the API response, the request is at some point cancelled. And we can pass it the name. So node.name. And then we get a response for this. Server response and error. We can say server, we don't really need the response and we have an error. And if we encountered an error. So if error is not nil, hey Chris, also nice to see you around. We are just getting started writing our first actual code, lines of code here that aren't copied or auto-generated. So it's starting to get exciting. Right, so if we got an error, we are just gonna return that error. So return nil error. We could wrap it with something, but we can do that at some point. And then we can check if we even found a server. So if server is nil, because get by name, it has the potential to, if the server does not exist, nil is returned. Because this is a pointer, it could return nil. So let's check for that. And if it didn't find one, we are gonna just return an error here, server not found. But if we do find one, then let's for now just log it out. Server, and we're just gonna paste the whole object here, write the whole object. And let's see what it turns out to be. We can get rid of the node name here and restart our process. It still crashed as expected. Invalid memory address or nil pointer dereference. Where did that happen? Didn't happen at the point where I expected it to happen. New request. Oh yeah. I was a bit too quick here. I forgot that I only faked this in here, but I never actually set the client, because we kind of need to like construct the client, give it an API token, and then use that to make the request. So what did I do? Why did I split the editor? Yeah, thank you. Let's close some of the windows we have here. Cloud and instances are the files we need. Okay, so in cloud, here we return instances v2, but we never set the client. We kind of need to do that. So let's actually put the client also in here, into the cloud provider. And then we can say the client is c.client. We just pass it through to the instance of instances v2, or to the struct. Okay, and then we kind of need to think about how we can pass in the token. And here we have the new cloud function, because we need to go in here and we could say client is hcloud.newClient, and we just pass it in here. Okay, so we always handle pointers of clients. So let's make this a pointer, and let's make this a pointer. Kind of important, because in the client we have things like that take a lot of memory, and we don't want to make a copy every time we pass it to another method, or struct in this case. But if we run this now, let's just try it. It's gonna crash again. Oh, it didn't. Okay, it just errors out, unable to authenticate, unauthorized, because we didn't put in an token. So we need to say hcloud.with token, and we need to kind of pass it a token that we need to get from somewhere. But from where? We have multiple options. We've got the IO reader here. Let's check out what that even is. Factory is a function that returns a cloud provider interface. The config parameter provides an IO reader handler to the factory in order to load specific configurations. If no configuration is provided, the parameter is nil. Okay, so what is in the reader? The configuration file for the cloud provider. Okay, I don't think we have a configuration file or a defined interface for the configuration file. So let's just read this from an environment variable. We can use the standard library here, os.getEnv. We pass it the string, and the default is in the Hetzel Cloud ecosystem to just use the hcloud token environment variable. For that to work, I quickly need to set it based on the API token we created earlier, but I can't show that to you, so I'm gonna hide my screen for a moment and figure that one out. Let's read it from the config file for this and edit the run configuration to set the environment variable. Okay. Let's get back to the other screen and try to run this again. And it crashes somewhere, which is something different from before. And we can actually see that now we get back a server. It has an ID, it has a name, it has a status, it has a creation date, and a lot of other fields that aren't properly logged because I should have just used %+v. And then we got the implement me panic, which is expected. Okay, now with the +v, we get to see the field names. So we have the ID, name, status, created, some information about the public net, and other stuff. Nice, nice. Let's implement our method here then. So we are returning a cloud provider .instance metadata and an error. Let's hope that the error is just nil. For the provider ID, the recommendation was provider ID is a unique ID used to identify an instance on the cloud provider. The provider ID set here will be set on the node's spec.providerID field. The provider ID format can be set by the cloud provider, but provider should ensure the format does not change in any incompatible way. Provider ID format used by existing cloud providers has been provider name, instance ID. Okay, we are free to use anything here, but let's just follow the lead. And just say provider name. Oops. Let's just say we got a string / and our ID. And then we have the provider name and the server.id. And that should be the provider ID. Then we have the instance type, which is like the server type in Hetzner Cloud speak. So we can get that from server.servertype.name. We could use anything else but the name, but I think the name is fine for our purposes here. We have a zone. The zone is the zone that the instance is in. The value set here is applied to the following labels on the node: zone and region. I think that region is the smaller scale thing and zone is the larger scale thing. No, zone is the... Let's look it up. Kubernetes zone region. This doesn't look like the right one. let's check out the well-known labels list, because this is where it ends up. A very interesting and important document, the list of standardized labels across Kubernetes. Always interesting to look at. So here we should have a zone. This label is also used as part of the topology hierarchy. See topology kubernetes.io zone for more information. Okay. The zone represents a logical failure domain. It is common for Kubernetes clusters to span multiple zones for increased availability. The exact definition of a zone is left to infrastructure implementations. Common properties of a zone include very low network latency within a zone, no cost network traffic within a zone, and failure independence from other zones. Might share a network switch. A region represents a larger domain made up of one or more zones. It's uncommon for Kubernetes clusters to span multiple regions. Okay. So we have three choices here in the Hetzner cloud world. We have the data center, we have the location, and we have the network zone. Private networks, load balancers, they can span one network zone. Servers are always in one location and one data center. So I don't think the data center distinction really makes a lot of sense here. So as the zone, let's just use the server.location, data center.location. .name. And as the region, let's use server.datacenter.location.network zone. Yeah, .network zone. Okay. That should be a string. Let's check it out. Yeah, it's just a alias type here for one of the three supported network zones. So let's just insert it back into its string. Okay, and that should be, oh yeah, node addresses. Node addresses. Let's write a helper function for this. Get node addresses. And we just pass it the server. So it gets a server, hcloud server. Nope. Like this. And then can we implement this? Create function. Yes, perfect. Golang is really helpful for this kind of stuff. I was using Visual Studio Code for a long time, but a coworker convinced me to just try it out, and it is actually really helpful to auto-generate a lot of stuff. Also test cases. Yeah, the debugging functionality, it's very nice. I like it. Okay, so what is a node address? A node address is a struct with a type, which can be, well, that's a lot. Didn't know that there are that many. Hostname, internal IP, external IP, internal DNS, and external DNS. Okay, and then it has the actual address just as a string. So let's think about it. The server definitely has a host name. Let's make a quick slice here. So the server definitely has a node address, definitely a host name, sorry, definitely a host name. So let's create a new one here. The type is v1.hostname. And the address should be equal to the server.name. At least that's the default in Hetzner Cloud, and it's what I would expect everyone to follow. Otherwise, we also get into problems with this code, because by default, the name of the node is the host name, and we can only find the server if that name is correctly set. Otherwise, you would need to get into patching the instance ID yourself if you want to use something else here. Okay, then we have the next one, that is external IP. And now the question is, should that be, let's actually put that into a function here. An if statement, I meant, sorry. Let's think about it. A server might have a public IPv4 or not, and a public IPv6 or not. And now the question is, does this expect us to return both or only one of them? Okay, it doesn't really clarify this, so let's just return both and see if it fails. So let's check if our server has a IPv4 address, public IPv4 address. We are gonna append that into our list. Need to convert it to a string. And we need to do the same for IPv6. So IPv6, and then that's IPv6.ip.string. Okay. Nice. And because we don't have any information about the private networks, let's just keep it that way. Because the server might be attached to multiple private networks, but really only makes sense to define one of them. So otherwise you might get into conflicts, I think. Okay, let's run this. Node synced successfully. Perfect. That's what I wanted to hear. And if we get back our watching command here that I forgot to run, it actually doesn't output anything. So the taints are empty right now. So if we get the node, we shouldn't see any taints in here. No, we don't. But what we do see is that the these are the beta ones. Yeah, here. That the instance type is set, as we did, and that the region and the zone are also set, as we would have expected it. Nice. Also, the addresses are available. And did we return anything else? The provider ID is also set. Perfect. And with that, we already have the first controller implemented. Or so you would think. Because if we look at the... Oh, let's make a commit from this before we continue. Feature working node controller. Sweet. Let's think a little bit about this. Right. The instance metadata. Let's check the documentation for this method. Instance metadata returns the instance's metadata. The values returned in instance metadata are translated into specific fields and labels in the node object on registration. Implementations should always check node spec provider ID first when trying to discover the instance. This is something that we haven't done. We just took the name and tried to map that onto the cloud. So let's rectify this and actually use the provider ID first and foremost, and the name as a second. Okay, so let's write a wrapper function for this, because we're also going to need it in these two methods here. So let's write a get server for node method that returns our server, and we pass it the node, and also possibly an error. Let's see, create function. Okay, this is a pointer to an hcloud server, and this is an error. Nice, and then we can take all of this and put it in here. Oh, we also need to pass it the client and the context. So context and the army.client. Actually, we could make it a method on the instance. Let's do that. Then we don't need to pass the client, and we just call i.getServer for node. And then we can do that by defining that this is on the struct instance v2. What's the issue? Unresolved type instance. Instances v2. Okay. That was the wrong method function. We wanted to do it here. Okay, let's define the context. Context. And then it should work. Okay, so this is just what we had before, but refactored. But that's not what we wanted to do. Because we actually wanted to first check if the provider ID is set and otherwise build it. So if node.spec.provider ID is unequal to an empty string. So if it is set to some value, we want to try to parse it. How should we do that? We should try to split it. Strings, what functions do we have? Cut prefix. Let's try this. Cut prefix. String is node.spec.provider ID. And the prefix is this one here. What's the issue? Cut prefix, oh, returns a found, which we can ignore. Actually, let's use that if not found. So in case we have a provider ID, but it doesn't match the expected format, I would say that's an error. So let's just return nil format.error f provider ID does not follow expected format. And then we just put in the provider ID that we got. So node.spec.provider ID. Okay, then we have the provider ID and we can try to parse it as an integer. For that we say we use stringconf.parseInt. String is provider ID. The base is 10 and the bit size is 64. And that returns an integer and an error. If we got an error, we're gonna say return nil format.errorf unable to parse provider ID to integer. And then we are just going to wrap the error that we got from parseInt. Okay, now we got the actual integer here. And the question is, what are we gonna do with it? We can just use i.client.server.getById. We can pass it the context, we can pass it the ID, and then that will return a server, a response, or an error. Is that actually what happens here? Yes, okay. So let's say server error. Let's define server here. Server hcloud.server. And then, oh, we got a parent response. And then this server is assigned to the variable outside of the if statement. And here we can just say if error is not nil, return nil error. And now we can wrap the getByName logic just into the else block. So if we have a provider ID, we're using this logic. And if we don't, we are using the getByName logic. Actually, let's also define the error here. I don't like that this is being shadowed now. Let's do it here. Okay. And as you've noticed, we didn't check that the server is empty because we're just going to do that here. If server is nil, then server not found, otherwise we return the server. Okay. That should be good to go. Let's see if we restart our process. Where is it? Run. You can see that it is regularly trying to call this again. So this was every 5 minutes. It tries to resync the node. So next time it does that, it should use the... Oh, actually, let's put a debugger here so we can see that it happens. Let's put a debugger in here. And let's see which path it takes. Oh, yeah, we got a bunch of other breakpoints now that we don't really need anymore. Okay, get server for node. And if we look at the node, it has a spec, it has a provider ID. So it should cut the prefix, get the provider ID. It should parse it as an integer. We get the integer ID. And then we call getById. And we get back the server. Nice. Now, we could kind of break this by updating the node to have a different ID, but I guess for now, this should be fine. Nice. Nice, nice, nice. We have made more progress than I expected. Any questions so far that I can answer? Just gonna give you a little bit of time. I'm gonna create a commit here. Okay, we might later realize that we need the get server for node method also in other contexts for one of the other controllers. Then we would need to move this outside of the struct to a generalized function. But for now, let's keep it this way. Okay. Earlier we faked these two methods. Let's clean them up a little bit. Instance exists. We can actually make a check. Just run get server for node. Let's just copy this from the other method. But in case we have an error, we actually want to check if errors is there a way to check if the okay, I'm gonna say let's, instead of returning a custom error here for server not found, let's return hcloud.server not found, error code not found. How can we signify this? Oh yeah, we can of course make a variable error not found. And then we can return error server not found. And here we can check if errors.is which way do we need to pass them in? Is reports whether any error in errors tree matches target. Okay, so error is the actual error we have, and target is what we want to check. So that's correct. So in that case, we want to return false because it doesn't exist, and the error is nil. In case, is there some documentation for what we should return in case we have an error? Returns true. Okay. So it doesn't really matter what we return here. We just return an error. And here we just return true and no error. And then we don't even need the actual server here. Okay. Sweet, sweet. For the instance shutdown, let's do something similar. Let's get the server. Actually, let's use this one. And if server.status equals yeah, basically if it doesn't equal running, we can just say that it's shut down. If okay, so we return not equal running. So if it's not running, we tell CCM that it's actually shut down. Okay. Let's run that again, just to validate that it doesn't crash. We should get rid of this logging statement too. This one. Restart. Okay, Did it sync the node? I don't know. The cloud provider library is a bit weird. It only does some of the things every reconciliation, but some others only the first time it adopts it. But I would expect the exists and the shutdown to be ran every time. We can actually put some breakpoints in here and validate that that happens. Doesn't stop. So mean. Well, maybe it has weird sync intervals for those. Oh, it just sent waiting for informer caches to sync. Sometimes I am really, what is the word? Let's check it out. Impatient. And I don't really want to wait for stuff to happen. Started custom lifecycle controller, sending events. Okay. Looks like it doesn't want to stop there. Let's see if there's some weird concurrent node syncs. Node monitor period. Default 5 seconds. No. It's not syncing every 5 seconds, right? That doesn't make sense. That doesn't make sense. Okay, but there aren't any better flags, so maybe it is actually waiting 12 hours on existing nodes. Who knows? Who knows? Okay, so that's basically the first controller finished with all its fun and glory. Let's make another commit. Feature implement instance exists and instance shutdown. Okay. Nice, nice, nice. I think I need to let some fresh air in here and take a break. But before that, let's take a look at which one we can implement next. Oh, actually, before we do that, let's do some hygiene around our API client here. With token isn't the only option you can set. You can also define a number of other things, number of other client options. We have some poll intervals. We aren't really doing polling right now, so that's not important, but we have an with application. also a with debug writer, which are very interesting because with debug writer allows you to see all the HTTP requests that we send to our API, to the hcloud API, and with the application sets a user agent on the request. So in case some API clients go bonkers, Hetzner Cloud has an easier time figuring out which ones those are and how to improve the situation and help customers. So let's set those. With the application is a CCM from scratch. And the version is, let's just not put a version in here for now. And then we have with the debug writer, and let's only put that in there when it's actually necessary or makes sense. How can we do that? That's accepts an array, right? So let's say options client option. If os.getEnv hcloud debug, then we're gonna append to, is there some way to like get a quick append? Yes, no, maybe. Okay, hcloud with debug writer, and is there some output we can get from klog? No, doesn't really seem like it, so let's just use std error for the logs. What's the issue here? Oh, that returns a string. Let's just trigger on anything but the raw, but nothing. So if it's set to anything, then we do that. And here, let's pass in the options. Okay. Nice, nice. Let's try this once more. I am... you're gonna see the secret if I open this. Okay, let's just keep it in there for later, and maybe we are gonna need it at some point. Yeah, okay, let's commit that. Git commit feature properly configure go client. And yeah, that's it for now. I'm gonna take a break, 15 minutes, I think. And then I'm gonna be back. See you soon. Thanks for yeah, coming by today. I hope so far you learned something, and yeah, see you later. Welcome back after a little short break. I hope it wasn't too long for you. I definitely feel refreshed. It's, I don't know, harder than expected to talk into a camera for 2 hours straight and do work and be watched all the time. Hello, Relonium. Welcome to my stream. Just coming back from a break, got some fresh air into the room. Let's do a quick recap of what we've done so far. I think that's a good idea to catch everyone up here. Also, my tech is kind of broken. I'm using a new IDE on this computer, and OBS doesn't compile in with WebSocket support on Arch Linux. So my Stream Deck doesn't work, and everything is kind of weird today. But I'm still happy to be here. Okay, let's switch the screen. Yeah, what we are trying to do, we are building a cloud controller manager from scratch. A cloud controller manager is a concept in Kubernetes that is a number of controllers integrating your Kubernetes cluster with your cloud environment. There are a number of controllers, and so far we have implemented the node controller during the morning hours. As you can see, let's get the node object open. Node. So far we have written back some labels to the node. The instance type, the region, and the zone, as well as set the provider ID and the node addresses. You can see that we get the external IP, IPv4 and IPv6, as well as the host name. Not sure if that is actually allowed, but as the library passed it through, I guess it's fine. And also because we returned some valid responses from our code, the cloud provider library removed the uninitialized taint, so pods can actually schedule on the node now. How did we do this? We started by just copying this bootstrap main.go from the Kubernetes Cloud Provider library into our project, which initializes the CLI command, the flags, the list of controllers. I still don't know what this method does, really. And then calls our cloud provider to initialize it and run it. Rather, this happens here. Right, then we set up a Kubernetes cluster. Cluster is a little bit of a big word for what we did, because we basically only created a server in Hetzner Cloud using an Ubuntu image with a specific server type, gave it the name cube, passed in an SSH key, and put it in a Falkenstein German location of Hetzner Cloud. And then we used k3s up to install k3s on the node and to get a cluster up and running. There's a lot of configuration. If you want me to go into detail what is happening in this command, feel free to ask. Otherwise, I'm just gonna skip over it. Yeah, now that we had a Kubernetes cluster, we could run our program, and it connected to the cluster, but it complained that there was no cloud provider with the name. We were running it like this before. Go run main, passing in a cloud provider name and a kube config, and another flag to allow skipping the cluster ID flag. And then it complained that it didn't know what hcloud from scratch is. So we defined our own cloud. We called register cloud provider, passing in the provider name, which is hcloud from scratch, and a method to instantiate a new cloud provider for this name. And in here we built a client for the Hetzner Cloud API using hcloud Go. And then we create a cloud provider struct. The cloud provider struct implements the cloud provider interface from the cloud provider library. Okay, maybe the naming wasn't that smart. But yeah, this struct, we could say var cloud provider dot interface is equal to cloud provider. Yeah, our cloud provider here implements the interface defined by the cloud provider library that we need to pass. And this interface is just an entry point, which in itself has a bunch of methods which just return the interfaces for the actual different controllers. So every type of controller has a different interface. Hey, thanks for the follow, Realonium. Every different interface has a method here, which just acts as a getter to that interface. So here we then implemented the instances v2 interface, which is used in the node controller. And we just, for all the other interfaces, we say, nope, we don't implement that by setting a value of false here. While for instances v2, we have it true. And then the library just calls all these methods, checks what it can run, and then just runs those. For instances v2, we have another struct also embedding an hcloud client. And this implements, let's do this again. This implements cloud provider dot instances v2, as the name would suggest. And this has three methods that are a little bit more focused. We have instance exists, instance shutdown, and instance metadata. Instance exist just needs to return yes or no, whether the node exists or not. Instance shutdown needs to return yes if it's shut down or no if it's running. We just return false if it's running, otherwise we return true. And instance metadata is the only really interesting one, but even that one just returns a struct with some metadata about the node. So we have a provider ID here, we have the instance type, we have a number of endpoints, node addresses that we saw earlier, the zone and the region. And that is being written back to the node object in Kubernetes. We skipped over one method, and that is the get server for node function here. And this one, it gets the node, and then it tries to resolve the node, the Kubernetes node, back to an hcloud server. The interface for instances v2 expects us to always first check if we have a provider ID already set, which is like the string we return here. Some opaque string set by the cloud provider that uniquely identifies the node in the cloud provider. So if we do, we define the format for this. Let's check that out. K8s node spec provider ID. Yeah. So the format is like a URL with a schema protocol, and then the value is just the ID. So we called it hcloud from scratch, / the ID of the node in the Hetzner Cloud API. So when we try to find the node, we just remove the prefix from this, then try to parse it into an integer and look up the server by ID. Or if the field isn't set, we just do a lookup by name. and then return the results from either of those and work with them. Okay, that's all that we got so far. Right now we are not running this in the cluster, but instead I'm just running it locally here in Goland using a run configuration. So we can quite easily run and debug it, and I don't have to set up some Kubernetes manifests that I haven't prepared and some development environment for that. And then we need to figure out what registry we push to, and all of that stuff can be avoided if we just run it locally for today. Yeah, that's what we did before the lunch break started. So let's think about what we want to do. What we want to do now. As I've already said, we so far have implemented the node controller. So there's the root controller and the service controller left. The root controller is a bit complicated. Well, the implementation isn't, but understanding what it does is a little bit more involved than the service controller. And also we would need to set up a private network for the server and pass in the configuration for that. So I would like to work on that later. So next, I would like to implement the service controller. For that, in our cloud provider struct that implements the cloud provider interface, we have a method here called load balancer. Let's check out the documentation. Load balancer returns a balancer interface, also returns true if the interface is supported, false otherwise. And then load balancer is an abstract pluggable interface for load balancers. Yeah. So it has a bunch of methods, unfortunately not as cleaned up as the instances v2. Get load balancer name, ensure load balancer, update load balancer, and ensure load balancer deleted. So let's get going. As before, we are gonna create a new file, call it loadbalancer.go, and then we are gonna create our struct called load balancer. Yeah. And then we are gonna tell Goland to please implement the interface for us. Implement interface cloud provider.load balancer. Then we can skip a bunch of boring writing and just get started with the interesting code. Picks up some imports here. Yes, I don't know why it doesn't figure that out from the other imports in the same module, but it's still easy to select the right one. Okay. And I already know that we need to talk to the Hetzner Cloud API. So let's also pass in the hcloud client here. Then where we initialize this in load balancer, we can return a instance of load balancer, passing in the client c.client. And as we now implement it, we return true in addition to the struct. Okay. Yeah. Let's try to run this. Actually shouldn't do anything because we don't have any services defined yet. So it shouldn't panic or anything, but it should say that it's starting the service controller. Yes, started service load balancer controller, which is what I was hoping for. So because we kind of need to have something to work with, let's create a new directory, examples. And in here we are going to create service lb.yaml. And then we are just gonna take some example from Kubernetes. That might be a nice one. Can we maybe get that a proper deployment? No. Okay, it's fine for now. Okay, so this is just a very basic example here. It creates a new pod with Nginx running. It defines a port, and then in the service we select the pods that the service should target, define a list of ports, and then we need to make one change to this to work for us. Okay, and that change is services have a field called type. Type determines how the service is exposed, defaults to cluster IP. Let's quickly create the service like this. So k apply sample service load balancer. And if we get the service and the next service, we see that it has a type of cluster API, and we also see that it has a field cluster API equivalent to a IP. And if we go into any of the pods in our cluster, so for example, exec nginx, okay, nice. It has a shell installed. Do we have curl? Yes, we have curl. If we just curl that IP, then it will return the response. This is a little bit of a bad example because we are getting the content from the pod through the service. We could also just do localhost and we would get the same response, but it's also available through the IP. But that's not what we want, and that's also not what our controller handles. As you can see, there is no log events or failures or anything, because with a cluster IP, we aren't responsible for it. We are only responsible for it when we set this value to load balancer. Means the service will be exposed via an external load balancer if the cloud provider supports it, in addition to node port type. Node port is still required so we can actually target the, we have some kind of port that our load balancer can target. Okay, so let's set this up. Let's make a change to our service here. Let's just say it's type load balancer. Let's quickly get rid of the existing manifest because I don't think it's possible to change this once it's created. Anyway, just deleting is cleaner. And then we create a new one. And now when we check out our service, we're gonna see that it is of type load balancer. We see that it has a status that now mentions a load balancer. And also we got some additional fields related to a load balancer and a finalizer that makes sure that the load balancer in the cloud is actually deleted when the service gets deleted, or rather it blocks the service deletion until the load balancer in the cloud is deleted, as long as we implement that properly in our Cloud Controller Manager. And now if we look at our run, we see that it crashed. Nice, isn't it? Event occurred, object default nginx service, kind service, reason ensuring load balancer. And then we observe the panic, and that's just the panic that Goland auto-generated for us on the ensure load balancer call. So yeah, that's the scaffolding. And now we can get into actually implementing the ensure load balancer method. Okay, let's quickly take a look at the way that you can configure a load balancer in Hepsa Cloud. First thing is you have a location where the load balancer is hosted. And you can also see a little one here, one server available in this network zone, because we have a server cube in Falkenstein, which is part of the EU Central Network Zone. And I mentioned it earlier, but you can create a load balancer and it can target all servers in the same network zone. So if we create it somewhere in the EU Central Network Zone, it can create the server there. If we would create it in US West or US East, it couldn't target the server that we're currently using. So let's just select Falkenstein. Then we have a type that needs to be configured, how big the load balancer is, how many services, targets, certificates it supports, and also how much money it costs. We're just going to use the smallest one because we are only going to have a single service, a single target for now, and no traffic. You can also add it to a network if you have a private network for your cluster, and you can add targets. For example, our cluster node. Then you can configure. Targets. Targets are just the targets that the load balancer sends incoming requests to. Then you can configure services. Services are the ports that the load balancer exposes and where it should send the traffic to. So for example, if we have a port HTTP 80 to 80, then the load balancer, the IP of the load balancer gets a public IP. It would send all incoming traffic from port 80 to port 80 on all the targets that it has, based on some rules. And the default rule is round robin. So it selects every node after another, but you can also configure least connections, and then the node with the least connections is going to get the traffic, the incoming request. We can also configure some health checks, some TLS, proxy protocol, sticky sessions, all the bells and whistles you can imagine. And then we can give it a name and create and buy. As I'm trying to get through content here and try to implement as much of the API surface as possible, I'm not going to go into as much of the Kubernetes API surface. I'm not going to go into implementing these advanced settings. I'm just going to make the basic to get a load balancer going, and then the rest is left as an exercise for the reader. So let's go into the ensure load balancer call. Okay. We are gonna start by, so in Kubernetes, you have the concept of a reconciliation loop. In a reconciliation loop, you always check what's the desired state of the world. The desired state is being passed to us by the service and the nodes. This is the service that should exist, and these are the nodes that should be a target for the service. Then you check what does actually exist right now. So we would first try to see, do we have a load balancer in the cloud? Does it have the right targets? Does it have the right services? Next, it would try to fix these. So if there isn't a load balancer, we would create a load balancer. If there isn't a target or there is a wrong target, it would add a new target, remove the wrong target, or do nothing if the target is configured correctly. And then the same for the service. So is the service configured, the Hetzner Cloud service configured as you would expect it? Is there maybe a mismatch between the destination port? Did it change on the Kubernetes side? Do we need to update it on the load balancer, Hetzner Cloud load balancer? And then it would make these changes. So the first step would be to get existing load balancer. Then we would, if none, create new load balancer. Then we would make sure load balancer config matches our expectations. Not sure if we actually need to do anything on the load balancer itself, or everything is configured through the services and targets. Possibly if you would like implement all of this, you would need to make sure that it's in the right location, it's of the right type, it's in the network, it has the right algorithm and labels, but we are just skipping all of that. We just need a load balancer. Yeah. Okay. So how should the load balancer be called? Let's see. So we have the cluster name and the service. So we could just say that the load balancer name should equal, because we somehow need to figure out what is the mapping between the load balancers in the cloud and what we are given here. And the easiest way is to just use the name as the connecting identifier, because that one is known deterministically from the Kubernetes side. Because we always have the same cluster name and we always have the service name. And if you delete and create a new service, you would just get a new load balancer. So we have the cluster name and we have the service dot name. Perhaps we should also put the namespace in here, but we're just going to skip that. But if you're writing some proper implementation for this, you should also put the namespace into this to make sure that you can have multiple services in different namespaces with the same name. Because in Kubernetes, a single resource is identified by the namespace plus the name plus the resource type, but we're only looking at services here. Okay. Now that we have the load balancer name, we can actually use our client dot load balancer, and we can say get by name. We pass in the context and the load balancer name. This gives us the load balancer, a response, and an error. Of course, if we encounter an error, yes, if we get an error, we are just gonna return the error. Actually, let's say format that error f. Unable to get existing, unable to check for okay. And then we can check if load balancer is nil, because get by name, if the load balancer does not exist, nil is returned, so we get a nil load balancer. Then we need to create a new load balancer here. So client.load balancer .new .create context and a struct with the options that we want to define. We already know what name we get. Oh, no. Yes. No. LB name. Wait a second. Can't we? Yeah, it accepts opts. So hcloud.loadbalancer create opts. Yes, this is what we wanted. So the name is LB name. The load balancer type is gonna be, what does it accept? Load balancer type. Okay, so we should probably get that from the API, but because this is just a demo, let's just say that we get a load balancer type, and let's just fill that in manually. So we can say hcloud load balancer type list and just use ID1 LB11. I'm not sure if it uses the ID or the name. So let's just do it like this. Name is LB11. Algorithm, I don't think we need to do these. Network zone is view central. Location would be, what type does it accept? A location, hcloud.location. Same here. Let's just pass in the values manually instead of getting them from the API. Location list 1 in Falkenstein. Labels, we're not gonna set any labels. We're not gonna pass any targets. Services, public interface, or network through right now. We're just gonna create a new load balancer, and then we're gonna reconcile the other fields later because we need to do it anyway. So we got a result and an error and something else. Did I? Oh, the response. Okay, so if error is not nil, we're just going to return an error again. And now the result has an action and a load balancer. The load balancer itself has a number of fields, and the action kind of is the asynchronous process of creating the load balancer in our backend. Because the API request is just finished like immediately once it's saved to the database, but then we actually need to provision the load balancer. Yeah, but we don't care for that. We just want the load balancer here. So we're gonna say load balancer equals result dot load balancer. And now we can continue and check the services of our load balancer. So for the services, we need to check two things. Do all of the services in our Kubernetes, or do all the, okay, a service in Hetzner Cloud load balancers maps to a port in a Kubernetes service. So we need to check, are all the Hetzner Cloud load balancer services, do they have a corresponding port in the Kubernetes service? And on the other side, do all the Kubernetes service ports have a corresponding Hetzner Cloud load balancer service? And are they configured correctly? So we need to compare the lists and then fix the differences. Okay, so let's check out what we got here. We got service.spec.ports. And then this has a port, a node port, a name, a target port, which we don't really care for. We basically only care for the node port, perhaps the port. Yeah, okay. And then on the other side, we have on the load balancer, we have the services, which each have a listen port and a destination port, and possibly a health check and protocol configured. Okay. How are we gonna do this? Okay, let's iterate through the ports of the service first. So for port in range service.spec.ports. And then we need to find the matching hcloud load balancer service. So how are we gonna map this? Let me check the explanation for a service. Explain service.spec.ports. K8s is really useful to get a quick, or kubectl explain is a really quick way to check out the API of Kubernetes objects. I really recommend using it. Okay. The name of the port within the service must be a DNS label. Must have unique names. Node port. The port on each node on which the service is exposed when type is node port or load balancer, usually assigned by the system. If a value is specified in range and not in use, it will be used. Okay, so this is the destination port of our load balancer. Then we have port, the port that will be exposed by this service. And we have a target port. Number or name of the port to access on the ports targeted by the service. Okay, we don't care about this one. We probably only care about the port. Let's check our service. Okay, get service. Yes, please. Okay, so we have the node port and the port, and then we just try to expose the port. Okay. So let's see our load balancer. Load balancer.services. Okay, if the service.listen port equals port.port, then we know that we have a match here, and this belongs together. Then we need to compare if the destination port matches. So if service.destination port equals port.node port, or rather, if it doesn't equal, then we need to update the service. Client, nope, c.client, l.client. Can we update a single port, single service? We can add a service. We can delete a service. We can update a service. Okay, perfect. So let's update that. The load balancer is what we got. The listen port is service.listen port, and the opts are hcloud.load balancer update service ports. Protocol should always be TCP, and destination port should be port.node port. And I don't think we need any of the others. Pointer int, and this is a int32. So let's run it through hcloud.pointer to get a pointer to the integer. Let's also force it into an integer. Okay. And if we have a match here, we're just gonna exit from the loop because there's no need to check the other load balancer services because the port is unique. Yeah. Now, if we haven't found any, no existing service found. Wait, does that make sense? This breaks this loop. I hate nested loops. Okay, let's introduce a variable here. Found existing service false. And if we find one, then we just say found existing service equals true. And then here we can say if no not found existing service. And then we can create a new one. So l.client.load balancer.add service, as in the context, the load balancer, what does it accept? Just some opts. Okay. So hcloud.load balancer add service opts. Fill all fields. Protocol, as always, is just TCP. Listen port is our port.port. Destination port is port.node port. And we don't need the others. Now they fail because they want to be an int and a pointer. Let's handle the error. Don't need any of the other variables. We are just not waiting for any actions because, yeah, we are just doing the reconciliation and then Kubernetes does a loop. And on the next turn, it will be configured or it won't, and we need to redo it. Don't really need to wait for the actions here. Okay. That's one way. The second way, which we are just going to put a to-do here right now, clean up LB services that do not belong to any service ports. Because yeah, right now we just create new services, but we never clean up services for ports in our Kubernetes service that are removed, that have been removed. Okay, I mean, we could already try this. Okay, no, let's do the targets. Let's do the targets too, and then try to check the targets. We are basically gonna need the same loop here. So this time we are gonna iterate through the nodes that we were passed in range nodes. As you might remember, we receive the service with the ports, as well as a list of nodes that the service should target. These might or might not be all the nodes in your Kubernetes cluster. For us, it will hopefully be the one node that we have. Otherwise, we're going to have to check some options. Okay. Again, we're going to define our variable here, found existing target, and then we are going to iterate through the targets in our load balancer for target in range LB targets. And if target dot y target dot targets target is a list of target. Why does a target have a list of targets in it? What? That doesn't make any sense. I quickly gotta check this out. Let's go into the innards of hcloud Go. Here we have a method schema. Sorry for that. I think I might got some leftover allergies. Load balancer target from schema. Yeah, it has a list of targets. Does the API also have a list of targets? Get a load balancer, targets. Oh, okay. That makes sense. Sorry, gotta blow my nose for a moment. Okay, sorry for that. Let's get back into the right screen. Okay, so the documentation states that targets is a list of resolved label selector target servers only present for type label selector. So what we are doing is we're going to add servers directly to the target list, but you can also define a label selector, and that will automatically add servers based on if they match the label selector. And then this targets reports back on the list of servers that were targeted. Okay. Interesting choice to use the same data type for this. Let's see. Where were we? Ah, yes, we wanted to check if target.server equals the ID of our node based on this logic here. So let's move that to its own function. Extract methods function. That provider ID. We don't really need it to have the server. Hello. And also we only needed to return one error and not two. Let's do the refactor. Nice. It cut away the wrong error. The one with the interesting stuff. Okay, let's try this again. Refactor, change signature. Let's get rid of the server and of the first error. Refactor, yes, this is better. This is better. Get provider ID. Let's refactor, rename this to error. Yes, thank you. And age should be nil in this case. Okay. Now we can reuse it in here, and we're just gonna say up here, the provider ID equals get provider ID for our node. Return the error. And then we can compare the server target.server. What shenanigans are happening here? Where are the API docs? Cloud. I haven't really worked with the load balancer API, so I'm a bit confused about what is happening here. Load balancer targets server ID server.id. Why is it server.server.id? Well, ain't gonna find out. So if the ID matches our provider ID, then we say found existing target equals true. Do we need to update the target? What can we update for a target? l.client.loadbalancer.update. Nope, there is no update target. There's just an add target, add server target, and remove server target. So really we can break out of the outer loop here. Break. This breaks through here. If found existing target, not found existing target, then we need to create the target. So l.client.loadbalancer.add server target. Context load balancer and probably some opts. Yep. gonna use the private IP, and we need to pass in the server. Let's hope that we can get by just passing in a ID for this, because that's the one that we have. Provider ID. Okay. I hope that should be it. In the end, the method, same as before. I'm not gonna do the cleanup of the targets for now. Clean up loop balancer targets that do not belong to any nodes targeted. Okay. It expects us to return a load balancer status. What is there? Ingress is a list containing ingress points for the load balancer. Traffic intended for the service should be sent to these ingress points. And that's just an IP, host name, or ports. It's a list of records of service ports. Used, every port defined in the service should have an entry in it. And port status is... okay. So we could wait for any errors here, but we don't need to define this. Okay. So in the end, return a new v1.load balancer status. Can we not fill in all the fields? Sometimes I'm really confused where the options are in Golang. Still. Okay, and the ingress is of type load balancer ingress. Why is it an array? Okay, we really only have one. And let's see what we got. We got the load balancer .publicnet.ipv4 and the IPv6. P is a string. Do we have a host name? lv.publicnet. No. Oh yeah, we do. IP and DNS pointer. And then we have a second one for IPv6. Okay. Let's run. Oh, at server target, we didn't handle the error here. Any other unhandled errors? Doesn't seem like it. Okay, let's see where we get. So far, we've only implemented one out of the 6 methods of a load balancer. So I don't think we will finish it quite completely today, but let's see where we end up. Let's start our process. Okay. Unable to create new load balancer, invalid input in field, in fields network zone and location. Now is the point where we can check out the hcloud debug environment variable that we defined earlier. I just gotta set it for a moment. Gonna hiding the screen because otherwise you can read my API token. hcloud debug, set it to crew. I'm just configuring an environment variable in Golang, and then I can share the screen again. Okay, let's try this again. And we're gonna see all the requests that are being made to the API. And here we can see cannot specify both location and network zone. Okay. Curious to know which location it puts it in if we only define the network zone. But for now, let's work with a hard-coded FSN1 location and just see where we end up. Well, we're gonna end up in Falkenstein. Okay, it complains that we got an invalid input in field protocol. Let's check out what valid fields there are. What call is this? This is the add service call. So in our docs, load balancer actions, add service, we can specify, oh, it's lowercase instead of uppercase. TCP. Is there maybe... yeah, there is a constant defined for that, so let's use it. Yeah. Okay. Error occurred. Event occurred, not error. Okay, nice. So we should see a load balancer as well as a target and a service. Let's make sure that it matches. Our cloud server is the target, and that also looks correct. Let's try to access this. And it's insecure, but it's our Nginx web page. Nice. Nice. So yeah, I mean, just getting started with the Cloud Controller Manager is quite easy if you know what you're looking for and what methods you actually need to implement. Usually just starting it and letting it run until it fails is quite nice. I'm really curious though, in what cases these other methods are called. Okay, so we could even return an API retry error if we have an action that we are waiting for, but we can't really pass them to the subsequent loop. Updates hosts under the specified load balancers. This is probably relevant if we add new nodes, then it maybe doesn't call this one, but just this method. This one is only called if we update the service. And deletes the specified load balancer if it exists, returning nil if the load balancer specified either didn't exist or was successfully deleted. Okay, let's try to delete our load balancer then and see whether that works. Okay, delete just the full example. And then we see it crashed here. Okay, before we implement that, let's add our changes to a git commit. Git commit feature create load balancers. Nice. Okay. Nice. Let's check out the docs for where is it? For the last one here, ensure load balancer delete, because this is where we crashed. Is that right? No, actually we crashed in get load balancer. Okay, so let's implement that one first. Let's see what the docs say. We just were there, but it's okay. Get load balancer returns whether the specified load balancer exists, and if so, what its status is. Implementations must treat the service parameter as read-only and not modify it. Okay, then let's check it out. And again, we somehow need to get the name of the load balancer. Let's make this a method then. Name. And then we can run this. Oh, why is there even? Okay, this is a free implementation here. Return get lb name, cluster name and service. Not sure where this is being called. Usages, scope, project and libraries. Test, just in some test code. Okay. Okay, I don't know. I don't know what this is. Actually, we could use it instead of get lb name, but I don't know. Yeah, let's do that. Oh, but then we need a context everywhere. Let's keep it like this and just use get lb name where we actually need it. Okay. So get load balancer, we pass it the cluster node, the service, the context, and it returns a load balancer status and whether it exists and an error. Okay. So if we encounter an error on get by name, we just return nil, false, and an error. If we don't get back load balancer, so if load balancer is nil, we return nil, false, and nil, because it doesn't exist, so we can't return a status. Exists is false, and we didn't counter an error. And as the last one, we are just going to return the load balancer status. Let's quickly make this a method. Refactor extract method. No. Can we extract it now? Refactor extract method. Nice. Get lb status based on the load balancer. We don't really need this helper variable here. Sweet. Okay, so get lb status, it does exist, and we didn't encounter any errors. Okay. Get lb name. Did I accidentally remove the code for this? Okay. Well, lucky for us, we already committed that. And also it's just these two lines. So return cluster name plus service.name. Do at, oh, let's just do it properly. Format.printf string, and then we're just concatenating the cluster name, the service.namespace, and the service.name. Now we made a breaking change, just so you're aware of this. And this would not find our existing load balancer, and that would stay in the cloud and cost money forever until you manually go in and delete it. So I'm just gonna go in here and delete it right now. Delete. Thank you very much. And then we use the proper name from now on, and we will create a new load balancer with the proper name. Okay, let's try to run this. It still shouldn't process the deletion, but it should fail in some other spot now. So previously we failed in get load balancer, now we fail in update load balancer. Why do we fail in update load balancer? Let's think about this for a moment. What does update load balancer do? Updates hosts under the specified load balancer. Read only. Okay. Okay. So it basically does what we already do in ensure load balancer. Are we doing too much here? It doesn't really say. Yeah, I don't like this interface. There's like so much overlap. What's the difference between update and ensure? Why is there a get load balancer? Why is there a get load balancer name? It's confusing, in my opinion. Okay, so basically update should do the same as we are doing here. So let's take all of this code and refactor it out into a method on our load balancer this time. Update LB targets. And gets a context, nodes, and our load balancer. Yeah. This is also just error. Okay. I don't like shadowing variables too much, if I can avoid it. Okay. Now we were in update load balancer, and update load balancer should do what we are doing here. So it should get the load balancer and probably fail if there isn't one. Yeah, there's just too much overlap between these methods. Okay, so it only returns an error. If it's nil, we're just going to return error f no load balancer found. And then we are gonna call, what is the method name? Update load balancer targets. Update load balancer targets, context, nodes, and the load balancer. And that returns the status and an error. We don't need the status here. And then we can just return the error. Okay. Or actually, let's make it if it does the same thing, but I find this a little bit cleaner. Just explicitly checking for an error and then returning that error, and then returning nil. Makes it pretty obvious what is happening here. Okay. Let's run this again and see where we end up. Okay, deleted load balancer. Oh yeah, because there wasn't the load balancer was already deleted, it probably received a exists false from get load balancer here, because yeah, it couldn't find the load balancer. Okay, let's try this again. Let's apply our example load balancer and then delete it. Oh, let's wait until it's actually provisioned. And show load balancer. Perfect. And then we can delete it again. Delete. And we're waiting, and we crashed again, but hopefully in another method. Yes, now we are crashing in ensure load balancer deleted and not in update load balancer or get load balancer. I know we could just implement all the methods and then try it out, but I like this approach of just seeing how far I get and then fixing what broke. Okay, so let's try to get the load balancer. At this point, we should probably refactor this into its own method. Maybe. Maybe not. Get the name. If load balancer is nil, return nil. That's what we hoped for, and otherwise we try to delete it by going l.client.loadbalancer.delete. Pass it the context, pass it the load balancer, handle any errors. We don't really want the response, we just want the error. And then if there is an error, we return it, and otherwise return it. Nice. Let's try running this again. And we deleted the load balancer. Let's check that it's actually deleted, and it's deleted. Nice, nice, nice. Let's do the full thing again. Okay. Showed load balancer. Processing service, retrying with exponential backup. Failed to update load balancer status. Service nginx service is invalid. Nil must be a valid IP address. Oh, because we didn't wait for the finish of the provisioning, and then the IP isn't there yet. But in the end, turns out to be fine after a few more reconciliation loops. That's the nice thing about Kubernetes. It hides the bugs you have in your code by just retrying stuff. Okay, let's try to delete it. And it deleted cleanly. Nice. Nice, nice. Is there anything else we need to implement? Is there any panic left? No, no panics left. Seems like we've implemented the full interface. I mean, there is some bugs around updating stuff. We never remove any additional service ports that we defined. We never clean up load balancer targets. But meh. I guess that's acceptable for this demo series. Okay. I'm gonna do another quick break, 5 minutes. Just get some fresh air in here because it's getting really hot. And then, yeah, I will be back at 13:55 CEST. See you around in a few seconds. Goodbye. Okay. Yeah, that was a quick implementation of the load balancer interface. Hacky implementation of the load balancer interface. Let's quickly recap what we needed to do for the load balancer. Okay. First we defined a manifest to test this. It's just a simple pod and then a service with type load balancer. Just exposing a single port here. Then we needed to define the load balancer client that our Cloud Controller Manager returns to the library, or the runtime for the Cloud Controller Manager. And here we just created a new struct and automatically implemented the interface that we needed to implement. And then we tried to create the service and observed what failed. And we needed to implement the ensure load balancer function. This is just a full reconciliation loop of the load balancer. So we start by trying to check if the load balancer exists in the API. And if it doesn't, we create a new one with some hard-coded configuration, because this is a quick and dirty tutorial and not a full production-ready implementation. For the production Headstart Cloud Controller Manager, we read these from annotations on the service. Because we get the full service here, you can just put annotations on it, and then we try to read from there, and then create the load balancer with that. Also, all the other settings that we omitted here are usually read from annotations on the service. Okay, we create the load balancer and then set it. Next, we check that the list of services match. In Headstart Cloud Load Balancer, services are ports that the server, that the load balancer is listening on, and then forwarding traffic to some servers somewhere. We do this by just iterating through the defined ports on the Kubernetes service and checking all of our load balancer services if we can find the matching service port. This is really confusingly named. If we do find one that matches, we check if the configuration matches, if we have the right node port as the destination port in our Headstart Cloud Load Balancer service, and otherwise update it. And if we don't find an existing Headstart Cloud Load Balancer service, we just create a new one with the expected configuration. We skipped updating, cleaning up Headstart Cloud Load Balancer services. So if you change the service, the ports in your service, existing ones will never be removed, which is fine for our case here. Oh, I forgot to share my screen. Sorry very much for that. Okay, let's quickly do this again. We defined the Kubernetes manifests. We defined our struct in the load balancer. We created a struct and then implemented the method ensure load balancer. Getting an existing one, creating a new load balancer, checking the services if they exist, updating if the configuration for the node port is outdated, or creating a new service if we didn't find one. Then we did the same for the load balancer targets. Because we needed another method, we refactored it later. So it's now in the method, in the function update load balancer targets. Again, we iterate through all the nodes in Kubernetes, check if we find an existing target on the load balancer that matches this node through the provider ID. And if we don't find one, we just add a new server target and therefore make the server part of the load balancer, the Kubernetes node. And again, we skipped cleaning up load balancer targets that don't belong to any nodes that are currently being targeted by the Kubernetes cluster. And we also need to return a status, which is just the ingress. Oh, I didn't show that yet, did I? The result of that. Let's quickly see how this looks like. Gotta start our app here, and then we can get the service. We can get the service at some point. Yeah, here. And we can see that our load balancer has an ingress with these IPs. And also we can see that if we don't do the YAML output, but the just list output, it's listed here as an external IP. Yay. Okay. Yeah. Then we tried to delete the service and found out that in order to delete, we needed to implement like 5 other methods that all do similar stuff. Get load balancer name, which just returns the name. Get load balancer, which returns just the status without reconciling it, and also a flag if it exists or not. We needed to implement update load balancer, which basically does the same thing as ensure load balancer, but only for the targets, not for the services and not for the load balancer itself. No idea why there is this overlap. I don't get it. And also, last but not least, ensure load balancer deleted, which actually deletes the load balancer. Or if it doesn't exist, that's also fine. Yeah, that's it for handling load balancers. I believe load balancers are the most complex if you actually implement all the features for it, like all the little knobs and sliders of your cloud provider API. Like we just skipped over here with the targets. You can't really configure much, but with the services, we could, for example, also have HTTP, HTTPS services. We could have health checks on different stuff. We can configure a proxy protocol. We can configure like TLS certificates that would then be served by the load balancer and adjust the TLS termination. We could make all of this. This is right now happening in a public network using public IPs. We could also make it happen through a private network using private IPs. Yeah, there's a lot of stuff that you can configure, which we just glossed over right now. And which we aren't gonna implement at all. Okay. What do we want to do today? Do any of you have any questions? Any suggestions what we should check out? Otherwise, I got some ideas what we can do, but I'm open for feedback. I'm also looking for feedback on the stream quality. It's the first time I'm streaming with a hardware encoder on my GPU, and Twitch tells me that the average stream bitrate is too high. And I also see some logs that it's sometimes up to like 25,000 kilobits, which I can understand that some people can't decode that. I hope it still works for most of the people, but I will definitely have to fix this up before the next stream. Okay, no wishes from you. Then we are gonna check out the Kubernetes manifests to get the Cloud Controller Manager running in the cluster. Let's start by creating a new directory, and we're gonna write a Helm chart for this. Can we create a new Helm chart in here? CCM from scratch is the name. What did it do? Let's move those up here. Delete that directory, delete these directories. Okay. It's crazy what an IDE can do for you. Helm chart for Kubernetes. It's an application. We don't really care about the version. We don't really care about the app version. Let's just keep it as it is. And then we have the values. Also lots of stuff that we don't really need to do right now. Because this is just like a simple example. Let's keep the image in here. Okay. Replica count should also always be 1. Yeah, no wonder most charts are so complicated if this is what's being auto-generated by your IDE. Don't need a service, we don't need the service account, we're just going to use the one that comes with Kubernetes. We don't really need nodes. From the helpers, service account, selector labels, common labels, maybe common labels. Chart name, full name. Okay. That should be it for helpers. Oh, okay, let's just replace all of this. CCM from scratch. We just have one replica. Oh, this is dangerous, right? Sometimes some of the stuff that's being auto-generated isn't too dumb. Okay. Sorry, this is not very cool what I'm doing here. maybe we should just write it from scratch. Let's write it from scratch. Sorry. Okay. Ooh. Sorry. What is this generating? Let's please just give me a deployment of YAML file, and we can do the rest ourselves. Okay. Let's check out what a deployment needs. No, I always forget what kind and stuff we need to write. Kind deployment. Metadata. We're gonna need metadata. Its name. CCM from scratch. We're gonna need a namespace. Because it's part of the core functionality of the cluster. This is being deployed to Cube system. We could use some labels, but we can also skip them. Let's write a spec. Oh yeah, we are gonna need an, I think this is an apps v1. Let's see, yes, apps v1. Okay. So we need a spec. Hey, here's Rusticus. Probably can't hear me right. Then got some issues with the hardware encoder today misconfigured right before starting the stream. It's trying to push 6 to 20 bits. Okay. Okay, the spec, the deployment spec. So deployment.spec, let's take a look at it. Paused replicas. We want one replica. We could do more and then have leader election, but skipping that is quicker. We need a selector. Let's just call it app, CCM from scratch. Selector match labels. Yeah. This. Okay. Then we have the template for creating the pods. The template has metadata, like labels. These should match the match labels, or at least be a superset of them. And then we have the spec, which is equal to this pod spec. Okay, pod spec gets more interesting. Here we have a lot of values. Most importantly, the containers. Containers is a list of containers that we want to run. So let's check out containers. We really don't need any of the others, except maybe collaborations. Gonna check that one out later. Okay, container. So the container needs an image. There's name, CCM, image, CCM from scratch. Scratch. We need an image, which is gonna be applicity, CCM from scratch, latest. Don't use latest tags in production. Always try to have an immutable tag. Also, apricoti is my name, so please put it into your directory, dictionary. Name ports. We don't have any ports. We don't really need resources. We do need some environment variables and some arguments. We already had a list of arguments earlier, so we need the cloud provider argument. And that should be equal to hcloud from scratch. We have the kubeconfig. Nope, we don't need the kubeconfig because this is being provided by the Kubernetes in-cluster config provider thingy. But we need allow untagged cloud. Actually, we could try to run it with cluster ID foobar and just see where this ends up. I'm curious to see what happens then. Okay. We do still need the secret with the hcloud token, which we are reading here. Hcloud token. Let's quickly take a look at how this is done in the Cloud Controller Manager, just so we use the same secret and it's compatible. Not really necessary, but okay, so it's just called token. We're gonna use and from, and we have a secret ref, and the name is gonna be hcloud, and the yeah, okay. Let's get some explanation for this. Spec containers and from secret ref name of the referent. The secret to select from secret and source. Oh, yeah, we don't want end from, we want end. And then we have the name, that should be hcloud token. Then we have the value from secret key ref. The key is token and the name is hcloud. I'm gonna quickly send you to the secret screen and configure the secret in my cluster. So you don't start hacking my project, because then I gotta pay for it, and I don't like paying for your Bitcoin mining. Token, where is the token? Drastico said, oh, actually the stream's video that is being saved currently still records properly. That's nice to hear. I was actually quite surprised that Twitch is even accepting like 20 mbits per second, because usually they have like a limit on that at 6 mbits. But interesting that it doesn't properly send it out again. Okay, I think I did it in the wrong terminal. Kubeconfig, and I can let you back in. Okay. So we got the stuff set up here. hcloud, let's also put hcloud into our dictionary. Yeah, right, and we need to configure a toleration, because there is a well-known label that is called uninitialized, thank you, this one, that is set before we are running, and we need to tolerate this so we can run. Let's see, the effect is no schedule, yes, and the key is this one. Operator exists. Nope. Operator equal. Okay. So that should be enough, I think. I mean, we still need to build the image and deploy it. But that should get us going from here on out. Yeah, okay. How are we going to build this? I've recently discovered Co, or I've recently started using Co. We could write a Docker file and use that to get started, but Co seems so much simpler. Nope, not Coca-Cola. Not Knockout. We want Co for Golang. Co for Golang is a simple builder and deployer where you just tell it to build it and then push it, and it automatically builds and pushes a Go binary for all the target environments, platforms you might need without having to write any custom Docker files. And it's very fast and doesn't need Docker installed, I think. So let's install that here. Cool. Yes, please. And then we can, we explicitly need to log in here. Do I need to provide the password? I don't like to provide my password to things. Our development setup deploys a Kubernetes cluster, then deploys a Docker registry into that cluster and sets up a port forward so everything is contained. But I just want to get the most simple thing going, and that is just using Docker Hub here. If you can push an image with Docker push. Okay, so I guess that already works. So let's see. Code Docker repo. Let's define that then. Export Docker repo equals ccm from scratch. Do we need to set? No, it works like this. Okay. So let's say co build. It's downloading the base image right now and then building the image. One reason I really like this is with the default Docker file, you need to do so much extra work to get the Go build cache working, to get multi-platform images working, And with co, you just say co build platform all, and it just builds all the images. But there is a problem. Writing SBOM had CCM from unexpected status code unauthorized. Okay, I'm gonna quickly do the Docker log indents. It succeeded. What is the issue then? Let's sign into Docker Hub. I mean, you can also use any other registry. It's just the one that I have configured and have used so far. Because it's free? Maybe because it's free. Do I have too many images? What's the... Okay, I've pre-created. Sorry, I'm gonna open the screen soon. Writing SBOM. Can I just tell it to skip the SBOM? Yeah, let's get you back in here. Let's allow you to participate debugging these issues. Okay, so we get a fail to publish images error building github.com. Cloudflare storage, Jenga image pro. Oh no, this is the wrong one. Publishing head, Docker.io, it uses the right one, CCM from scratch. Blobs. Unexpected status code unauthorized. Writing SBOM. Let's try without SBOM. SBOM is the software bill of material, the list of dependencies you're using. Might be that that's just not... Okay, let's try export code Docker repo just apricot. Because it looks like it's trying to do that with a sub. Yeah, okay, that works. Nice. What's the image that it just published then? Okay, so it does like a weird suffix. That's currently private. Let's just make it public, so we can pull it more easily. And we should see that we got an image here. What's the size? 100 kilobyte with one layer. Yeah, thank you. This is the SBOM. Okay, this is the SBOM. The actual image is still 34 megabyte. Way smaller than any Go binary you would usually build. Let's maybe check out one that I built at some point. Okay, 10 megabytes. Quite nice. So maybe it's not as small as I thought. Okay, nice. Now we got an image. We kind of need to update the tag in our deployment though, because it built like this weird suffix into it. And then we could try to deploy this to our cluster. Let's try that. Can we do a Helm install from a local repository? install from local folder. Okay. So we can just say helm install CCM from scratch fart. And that deployed it. Hey, nice. Deployments and system. I already noticed that we are missing one thing. It should be running. Let's check it out. k8s, thank you very much. Pods, crash loop back off, unknown flag cluster ID. Okay. So what is the actual flag for this? Logs 1 hour, please. Just stops there. Right. I don't know why k8s doesn't want to show me the full logs. It's always annoying. How does it work? Oh, maybe because we said we don't support. Where was that? At some point we said we don't support cluster ID. Yes, this one has cluster ID. True. Does it show up now in the list of flags? I really don't know what it does. If we don't find it now, we're just gonna remove it. Cluster name? No, no cluster ID. I don't know what that feature does or is. So let's just set that to false. In here, let's say allow untagged clouds. Set the flag, go run. Hello untagged cloud. Let's stop the one running here locally. And instead try to deploy. Oh yeah, we're still missing one thing. And that is the service account. The Cloud Controller Manager needs to have some kind of authorization. When I was running it locally, it was just using my admin config. But that doesn't really work for in cluster. So let's see, the docs for Cloud Controller Manager have a list of permissions that it needs to have. And also there should be a cluster role, I think, Cloud Controller Manager. Let's see. Okay, get cluster role. Okay. Then let's add this to our chart. rback.yaml. We're gonna need a cluster role. We are gonna need a now I'm just gonna auto-generate it. We're gonna need a service account. Hello? Doesn't do service accounts. Okay, thank you very much for nothing. Okay, explain service account. So kind service account. Okay, thanks. Metadata name about controller manager namespace system. Okay. And then we need to have a cluster role binding. Find cluster role binding to bind the cluster role to our service account. Cluster role binding is not in a namespace. So we have the role ref, which is this one. Cluster role API version group and name load controller manager. And then we have a list of subjects. Okay, and that should give our Cloud Controller Manager, or rather the service account, permission to do these things in all namespaces. And then we need to add that to this deployment. How do we do this? We explain deployment. Service account name. Service account name is Cloud Controller Manager. Okay, let's try to install this again. Install cannot reuse a name. Okay, upgrade. Install. The problem is that install only handles the first installation, while Helm upgrade install can upgrade or install depending on where you are in your life, in the life cycle. Thing. Fail to create resource, cluster role binding is invalid, subjects, namespace, required value. Okay. Namespace is cube system. Nice. Let's check it out again. K8s. And we see that they are still crash loop backoffing hello untagged clouds. Didn't I fix that? Didn't I make it? No, I failed. Okay, let's Helm upgrade again. And we can see that we got a running pod. Nice. Unable to get config map in cube system. Let's check our role. Config map. Nope, config maps are not part of this. Why are they not config map in here? Weird. Okay. What does it suggest? Create role binding, cube system, role binding name, role extension API server authentication reader. Okay. Yeah, okay. Let's add that one then. This time it's not a cluster role binding, but a role binding, which is scoped to only a single namespace. Namespace Q system. And let's name it extension API server authentication reader. And that's the role. Sorry, stumbling a bit through this. So the role ref is a role now. It has this name and it's a namespace Q system. We don't need to define that because a role binding is namespaced anyway. Okay. Let's try again. Let's open another one here. Another window so we don't need to. Did I just leak something? Yeah, gonna replace that later. Open k8s. And then we can watch the new one. Crash loop back off. Let's create a new pod here and watch the logs. And it seems to work. Nice. Nope. Error retrieving resource log. Why is this list so outdated? I'm just gonna to make it a little bit quicker. I mean, we could just go through this and fix bug after bug, or I need to close tabs. Or we can just copy a list that I know is working from our upstream Cloud Controller Manager. Oh yeah, okay. I mean, that's another solution. Okay, so it seems like we aren't doing fine-grained RBAC. We are instead just giving the cluster admin role. Perhaps that's something that we should fix, maybe, at some point. Feel free to open a pull request for that. Yeah, cluster role binding. Okay. That does make it way simpler. But it's bad practice, I think. Cannot change role ref. So let's delete that. Okay, delete cluster role binding Cloud Controller Manager. And then upgrade the chart again. And then we get an unauthorized because the service account doesn't exist anymore or something like that. Where's our deployment? Deployment. 0 out of 0, but we have 1 replica. I'm dumb. I didn't only delete the cluster role binding, I also deleted the service account here. We still need that one. Let's try this one. Okay, and looks like it works. It actually ensured the local balancer, and yeah, that's what it's supposed to do. So now we got our thingy running in the cluster, our cloud controller manager. Let's quickly add all the things. Git commit feature at Kubernetes deployment. And I got one last thing I want to do today, and that is set up a nice workflow for development, because now that it's running in the cluster, running Helm upgrade, building the image manually, it sucks. You could always run it outside of the cluster, but I like to run it in the cluster, because then you also like notice errors with the RBAC, notice problems with your deployment YAML that you wouldn't otherwise. For that, we are going to use Scaffold. Scaffold is another tool by Google, like Co. Let's install that in the background while we check out the docs for this, maybe. Oh, Scaffold init. Gonna use that later. Yeah, it's just running client side. You define a list of there's so many charts. I'm just gonna show you what it can do, and then you can decide for yourself if you like it. Let's remove the existing file and then scaffold init. And we see here that it will create a new config file with a builder using a build pack. Not sure what that is. And it also auto-detected that we have a chart in here that it's going to use for the deployment. Yes, I want to write that. And then we are just going to go in here and... Hello? Where is the file? Yes, sometimes the file explorer in Golang is a little bit slow. We are just going to go in here and tell it that it wants to use co instead. And that should be it, I think. So now we can say scaffold dev, and it will build an image for us, push that to the registry, and automatically roll out the chart with the image in it that we just defined. Well, rather it would if there weren't any issues. Let's see, there's a flag to keep our changes so we can check it out later. Was that clean up maybe? Clean up, clean up, clean up, clean up, clean up, clean up, true. Let's set cleanup false. Cleanup equals false. Service account not found. What? Don't we have that in here? Service account, cloud controller manager, namespace kube system. Oh, probably because this isn't being installed into the... It is kube system. Controller manager. Let's try it again. What is the issue here? There is one running, it's working. really don't know what the problem is. Happy for any help. Also gonna take a look at the config that we have in our repository. It's still using like the Docker builder, pushing to a registry. Namespace. I mean, let's use a namespace. Okay. Delete service account and k8s system. So maybe it was a problem around the namespace here. Service cloud controller manager. Let's try again. But don't we? Yeah, we have a namespace here. Weird. Release not found. Ah. Okay, delete. Yeah, there is a reason why people say throw away and make a new with Kubernetes. Sometimes you get into a state where cleanup is really annoying. Because you borked something up a long time ago. Delete deployment. Luckily, we only have these 3 resources and not many more. What? Let's watch events in namespace kube system and perhaps we see what the issue is. What? Created, started, stopping. What? Namespace kube system, cloud controller manager. Controller manager, cloud controller manager, kube system. Deployments, users, service account name, cloud controller manager. In namespace, kube system. What? I know that it works for our chart. Yeah. I don't get it. Let's try to just install from Helm once more. has been upgraded. Happy helming. And is it working? Yes. What if we uninstall this? Let's try once more. What? I don't get it. Service account. Do I have a typo in here? No. Hmm. I don't know. It was supposed to be a nice ending for today. Let's see, maybe we can tell Scaffold to be a bit more chill. Very important, being chill. Manifests Helm. No, we use deploy Helm. Oh, what do we use upstream? Manifests Helm. Let's test this one. Manifests Helm releases. Okay. Anything else? Nope, not really. Let's try. What? I don't get it. But also, my time for today is over. Thank you all for watching. Sorry that the last bit didn't work out. I'm gonna debug it locally. And yeah, I'm quite happy with how far we made it today. Getting a full implementation of a Cloud Controller Manager in. Getting half an implementation of a Cloud Controller Manager in. Really exceeded my expectations. I hope you learned something, you had fun watching me. And we are gonna continue this in 2 weeks at the same time. Next week I'm gonna be in the office, not working from home. So I want to spend time with my colleagues, but the week after that I will be back home and we will continue this. Hopefully fixing this issue with Scaffold and doing some more stuff around this. Yeah, very well. Thanks for coming by, and yeah, See you around. Goodbye.